Hello everyone, welcome to Neso Academy. In the previous lecture, we have seen design units, which are the building blocks of a VHDL program. And till now, we have completed the major parts of a VHDL code: library, entity, and architecture. Now, we already know that one entity can have multiple architectures. So the question is, from multiple architectures, how does VHDL compiler decide which one to select? And the answer is using a design unit known as configuration declaration. So today's lecture is all about configuration declaration. In this lecture, we will cover only one topic, which is configuration declaration. In this topic, we will understand its syntax. So, let's start the lecture without any further delay. In the previous lecture, we have seen that design units are the building blocks of a VHDL program, and each design unit can be compiled separately and stored in a library. And there are 5 types of design units, from which we have already completed entity, which defines inputs and outputs of a system; architecture, which defines the internal logic. Now, let's see the third design unit, configuration declaration. So, one entity can have multiple architectures, and configuration selects which architecture is used for an entity. Means configuration selects which architecture to be used for an entity. Overall, configuration connects an entity with its architecture. Now, one entity can have multiple architectures. Example, entity E1 having architectures A1, A2, and A3. And each architecture describes the system in different ways. And configuration is used to select one of these different ways. So overall, configuration selects one architecture from multiple. Means if an entity has multiple architectures, configuration selects one architecture from many. So I hope you understand the definition clearly. Now let's see the syntax of configuration using an example of AND gate. We have already seen the VHDL code for an AND gate. Let's take the same example, but with multiple architectures. The code starts with entity declaration with entity's name and underscore gate, as this is the example of two input AND gate. So, the inputs are A and B and output is Y. We define inputs and output inside this entity, and this block or this design unit is called as entity declaration. Now, for this entity, we have two architectures. The very first architecture named as data flow. So, architecture data flow of entity and underscore gate is. We will define our logic after begin. And what is the logic? Logic is output Y is assigned A and B. We are using the keyword AND. AND is a logic operator, acts like a real AND gate. So the logic is output Y is assigned A and B. Now the name data flow is not random. Yes, naming is flexible, but data flow represents flow of data from inputs A and B to the output Y as a concurrent statement, which means if inputs A or B changes, then Y, the output will change immediately. Now, we are done with the logic declaration. We will end this architecture using keyword end and the name of architecture data flow. Now, the second architecture named as behavioral. So, architecture behavioral of entity and underscore gate is. Here, we define the logic inside the process block. Now, what is a process block? A process is a functional unit which describes the sequential behavior inside the hardware. Means, process block uses sequential statements such as if-else condition. As per the name, behavioral. If-else condition describes the behavior of two input AND gate. Now, what is the behavior of two input AND gate? If inputs A equals to 1 and B equals to 1, then output Y will be 1, else output Y will be 0. After logic declaration, we will end this process using keyword end, and after ending the process, we will end this architecture and behavioral with name of the architecture. So overall, one entity have two architectures. Now how to select one of these? Using configuration declaration. Example, let's select data flow architecture using configuration block. Now configuration declaration will merge this entity and architecture. Means configuration will bind this architecture with this entity. Now let's understand the syntax of configuration declaration. So the code starts with the keyword configuration. Configuration keyword defines the configuration name. Means configuration keyword declares that we are starting our configuration with a configuration name. Now the configuration name, example, CFG underscore and. The name is flexible, similar to entity and architecture. Means you can give any name. So configuration CFG underscore and of entity and underscore gate is. The keyword of tells which entity is configured. Means of keyword tells we are using configuration CFG underscore and for the entity and underscore gate. And the last keyword is used to initialize the body. Means keyword is starts the configuration block. Overall, first line declares the configuration name for the entity and underscore gate. Now the second line starts with the keyword for. For keyword selects the architecture for the entity. Example, we are selecting the architecture data flow. And after the selection of architecture is done, we can end this selection using the keyword end for. So, keyword end for is used to end architecture selection. And after the architecture selection is completed, we can end this configuration block using the keyword end with the name of the configuration CFG underscore and. So, keyword end ends the configuration. So overall, configuration CFG underscore and will select the architecture data flow out of data flow architecture and behavioral architecture for the entity and underscore gate. So I hope you understand the syntax of configuration clearly. Before we end this lecture, one important question. What happens if we don't write this configuration block? The VHDL compiler will automatically select the last compiled architecture, means the behavioral architecture directly. So, in order to select a particular architecture, we need to mention this configuration declaration. Now, we are done with our topic, configuration declaration. In the upcoming lectures, we will see about packages in detail. Which means we are done with this lecture. I will see you in the next one. Thank you.